This is Inside the Logic, real talk with FPGA engineers. And in today's episode, we're going to pull back the curtain on what it's actually like to be an FPGA engineer. And we're going to talk about kind of what's next, what's coming in the future for this amazing technology. Of course, I am always joined by Charles Sobchak and Ryan Erickson. Guys, how are you?
Doing great. How are you doing, Kevin?
Can't complain. Ryan, you hanging in there?
Doing good. Glad to be here.
Awesome. Well, I'm excited for this one. We're going to kind of get a little behind the scenes and kind of pick your guys' brains about what it's like to be an engineer, what you think the future holds, and kind of go from there. So, Ryan, I'm going to start with you here. What kind of drew you into this path, and why did you choose this field, and maybe also mention kind of what you're doing now for concurrent real time.
Sure. So I'm going to be completely honest with you. I really did not want to be an electrical engineer. I tried everything I could not to be because my dad was an electrical engineer.
Wait, who's your boss?
My dad was an electrical engineer, and his dad before him, and then his dad before him. So it's a family trait. And so, as a teenager going into college, I tried everything to rebel against the idea of being an electrical engineer. And so I took some, basic, very broad engineering courses. And unfortunately, the thing I started to fall in love with was the electrical engineering side of things. And so, very early on, changed my major into electrical engineering. And I got to my first FPGA design course and fell in love with it immediately. And to be completely honest with you, a lot of my love towards and intuition towards FPGA design came from early childhood video games. Truthfully, it's very logic based, very decision based, very it's a lot of skill expression. It's a lot of design. Like you have to figure out how a strategy you want to approach things. Like algorithms are akin to any like design video games that I played when I was a kid, and so it just felt like picking up where I had left off because I was a big video game player when I was a kid. And so
I'll bet your young video games were different than mine.
Maybe, yeah. I would say a little different, possibly.
I was just making a frog run across a road.
Yeah, they had 3-dimensional games when I was a little kid, so it was nice. It was
definitely better.
But so I, it is this facet and field of electrical engineering that really, really felt in nature to me, and it felt like it opened up a lot of my ability to be creative and to really apply what I learn. And it's difficult, like we've said in previous episodes, but it's really all about what the person can do and what the person can design, and every little thing can be optimized to the point where it really is like a language. And I fell in love with just the real aspect of it and how it's difficult. There's always room to grow. There's always new things to learn. The skill ceiling is super high. You can talk to engineers that have been doing this for 30 years and you might be able to teach them something and they can teach you something. And it's really cool. And so what that has led to me doing here is I got pretty lucky straight out of college being able to find a job where I'm able to do some pretty hefty design work almost immediately. And so I have been able to pick up some responsibility here of, as a young engineer, having access and kind of being given the keys to the car. I can drive my own projects. I'm given the opportunity to design my own designs, my own solutions, and not necessarily needing to have my name at the top of the paper, but it's nice to be able to have a sense of accomplishment pretty early on into my engineering career, because I speak with my peers and I learned that a lot of them in their first 2 or 3, even 4 years is a lot of email pushing, a lot of design document reading, and I got to hit the ground running here. And so a typical day in FPGA Workbench team and concurrent real time is that there isn't a typical day. It's some days
that's what keeps it exciting, right?
Yeah, I know, it's great.
Yeah.
It is a very exciting job. Some days we're creating a very custom solution for another customer, and other days we're creating products that we've had on the roadmap for a while. And then other days we're shipping a system in manufacturing and helping test this giant rig that's going to a customer. And some days I'm working on installation, and it's just you never know. And it's really cool because from a job description perspective, my job is probably 90% design, 10% other stuff. But being in a small company, it comes down a lot of times to closer to like 60-40 or 70-30, where it's like, yeah, I'm doing design work, but on any given day, that design work can be very different from what it was the previous day. And then even with that, being in the small company, we do a lot of different aspects. And some days I'm talking on a podcast. Some days, some days I'm doing. It's a lot of fun though.
Yeah.
It's really cool because you never really know. You can have a good idea what the day is going to bring, but you never really know what you're going to do when you come in that day. You can have a plan, but the plan can only go so far.
Do you have any advice for people that might be entering embedded or real-time systems, or maybe thinking about going in this direction?
Yeah, my advice right now would be not to use Chat GPT for your homework. But in all honesty, it would be make sure that you want to do this because you're going to be dealing with a lot of people that love it, and
Mm-hmm.
so it's very much a you got to buy into it because it is the future, and like I'm sure Charles will talk about more later. AI is the future. What we're doing here is going to be it's going to be the main focal point of the next 5, 10, 15 years. Hell, it could be, excuse me, it could be the main focal point of next year. It is a very, very interesting and deep field of design work. It is very intricate. There is a lot to it. And so my advice would be don't jump in if you don't want to jump in. It is, I'm not saying it's a bad thing in any means. It's great, but it is very deep. It is a deep swimming pool. It is a deep pool of knowledge, and everyone that is here wants to be here. And
Mm-hmm.
so it would be tough to jump in if you don't want to be there.
Charles, how long have you been doing this?
Oh wow, a long time. So right, well, for FPGA work was a little later, but right out of graduate school, I was primarily in research, signal processing research, so inventions, patents, and those sorts of things. And then I spent a lot of time in the ASIC world developing ASICs for 2G, 3G, LTE, basically signal processing algorithms, demodulators, channel equalization in ASICs. And then I spent a lot of time afterwards in a government group working on proprietary communication protocols, wireless stuff, and signal estimation. So at this company, I've been here 7, 8 years managing the FPGA team, which is a little bit different. I've never really worked on a product, and this is very much a product. So
Sure.
it's been some challenges for me too, but it's exciting, and it's trying to think in a different way rather than just thinking from an innovator's perspective, thinking of how do you make how do you make the product work for the customer. And so yeah, so it's been exciting and fun.
Ryan alluded to this a little bit before about the impact of artificial intelligence,
Yeah.
machine learning, and how this is being, the acceleration on FPGAs. Can you kind of talk a little bit about that? What you're seeing? I know this is moving fast, so like,
Yes.
someone could watch this 2 months from now and it could be outdated for all we know. But what are you seeing? What's been happening, and where do you see that kind of acceleration going?
Yeah, I think kind of as we started to allude to, I think in the first episode, was that we're seeing, the sort of concept of low latency being a very high priority for customers, especially government customers. And with that, if you're going to deploy an AI or machine learning algorithm, so it's not just algorithmic compute at the edge. It's now AI inference or machine learning at the edge, right? And if you're going to be doing that at the edge rather than in the cloud, an FPGA is really an ideal piece of hardware to be doing that on because of the benefits, the parallelism, and especially the low latency. And so I think in my mind, I think that we're going to see more and more opportunities to be deploying targeted trained AI and machine learning algorithms on an FPGA. I mean, it's fantastic that we can, you know, use an LLM and ask questions and send tokens up to the cloud and then get information that is very accurate, ideally accurate. But it takes a long time. So that's sort of a function of how accurate is that information that you're sending up. When we deal with edge devices, some of the goals are a little different. right? So you're going to have a targeted application that you're going to want to run a lot faster. And so you're going to need the update rate to be faster, and you're going to need the latency to be as short as possible. In the same kind of realm as if you need to detect an object that's moving, you need that feedback as fast as possible.
Right.
So the AI and the ML is rapidly going towards FPGAs and figuring out it, but it's challenging to implement, but we're seeing a lot of opportunity there.
Are there new tool chains? Are there new ways of going about this because of these new the shift towards AI and machine learning?
Yeah, I mean, definitely. We kind of view it from two perspectives. So, in one sense, there's a benefit on the LLMs being able to actually physically write the code for you. So we use that as an opportunity to lower the barrier to entry. We talked about it a little earlier, where not anybody yet, because the Verilog and the VHDL coding in the LLMs isn't that great yet. It will be, but so you can use the LLM to write your own code.
Mm-hmm.
But the second area that we're focusing on that's heavy on our roadmap is we want to be able to develop a mechanism so that someone can take their trained model and get it onto our FPGAs. In the same way that, as we were discussing, you could be dropping a waveform and some adders and multipliers into the canvas and be doing that testing in the same day. We want to be able to shorten that loop. And so that's kind of the tool chain that we're trying to work on on our FPGA workbench team. So we're imagining using both of them, LLMs, to improve the method with which we develop the code, and then also just a direct pass through where somebody has a trained model, whether it's ResNet or whatever trained model, maybe it's imaging or maybe it's audio or frequency spectral analysis, where they have their trained model potentially on their proprietary data, and then they want to deploy it as fast as possible for an AI at the edge.
As we finish up today, I'd love to get your guys' perspective on the future. Ryan, what excites you about the next, say, 2 to 5 years? Although that's probably so far, maybe even 1 to 2 years. Like, what is exciting you as far as the future goes?
Well, a lot of it, has to do with, like Charles was saying, the AI and a lot of the ability to reconfigure FPGAs. And so, for the longest time, the kind of word around the street was anything an FPGA can do, an ASIC can do better. And the idea there being that ASICs could be slightly faster and more optimized for a specific solution. But now, for what might be the first time in history, that is just demonstrably false, because now the reprogrammability is no longer necessarily going to be used for development purposes, but it now is allowed for potentially an AI, artificial intelligence, to be able to make these changes and not necessarily be something that a human has to do. Because in the idea of there's not going to be an FPGA right now. There's no FPGAs inside your cell phone. There are ASICs inside your cell phone, but that's because there's never a human going in and changing anything inside of the ASIC. And so now with FPGAs are really positioned to be in the forefront of future developments and future changes and massive upheavals in what we understand as the current design flow in engineering. And truthfully, what excites me about that is that FPGAs are like my favorite thing. It's the same idea of like your favorite team winning the Super Bowl and being really good for a while, because it's like, all right, this is what I wanted to do, and it's about to kick off to be even stronger in the future.
Mm-hmm. Charles, how about you?
Yeah, I mean, it's scary and super exciting. I mean, in both perspectives. I know years ago when I got out of graduate school, our research team, we always had this analogy that the half-life of knowledge was 7 years. So basic idea is you get out of graduate school, and then 7 years later, the value, however you want to place, or you determine that value, monetary or what have you, is worth half as much. So we know as engineers that we have to keep learning and pushing ourselves. But now fast forward to today, and no, it's not 7 years. I mean, right, the half-life to knowledge may be a year, or maybe it's 6 months. And as we vastly approach that paradigm shift, it certainly can be scary, but I don't really view it like that. I think I really view it more as opportunistic, because when there's those paradigm shifts in science and technology, it's really opportunity. And where you can see aspects of friction in systems, if you remove the friction and you make it smoother, which is kind of like what we're trying to do with our tool, and you make it quicker for somebody to do that development, it's huge opportunity. And not only is it opportunity specifically with the tool, but I think there's opportunity in others, maybe other sectors or other fields where we haven't done a lot in robotics. But I think that there's a lot of merger of things going on right now, and it's exciting. It's just really exciting, and it's fun to be part of it, and it's fun to see FPGAs, which were a little bit more, again, like we said, a little more traditionally in the government sector, but to become really more in the forefront, and and that's what I see coming in the future. I think it's exciting.
Yeah, it's definitely wild times we live in, but fun. Like you said, there's even at the more fundamental or even at the more general level AI and these kind of things. It's both exciting and scary at the same time. But I'm with you. I lean into the excitement of it more. I think that's just, first of all, it's easier on the psyche, but also it's cool. It's fun. All right. Well, thank you guys very much. Really appreciate all the insight. And thank you for joining us today on Inside the Logic, Real Talk with FPGA engineers. Charles Sobchak, Ryan Erickson, as always, thank you guys so much.
Thank you, Kevin.
Yeah, thank you for having us.